Students with special education needs is one of the vulnerable groups in society, and their needs have to be taken care of. Now, SciCamp, in collaboration with Caritas Local School, is presenting you Collab Box, Help Job, learning and playing aids for special needs students. Collab Box, a short form for collaborative box, while Help Job implies help job, collaboration. Help, a container, and job, the crafts and work we have made.
Our partner, Caritas Local School, is a special needs school that accommodates students with severe physical and intellectual disabilities. The main mission of the school is to provide education and vocational training to inculcate self-reliance amongst the students. However, there's a wide range of disabilities amongst the students, and most of them being severe. So obviously, their classroom structure is very different from what yours and mine is. Students of more severe cases are accompanied by caretakers, and a classroom contains no more than 6 to 10 students. Yet, the classroom teaching is very individual focused. Even though this ensures that each student gets enough attention and a customized form of learning to cater to their own needs, we feel that there's a lack of student collaboration. And this is what we wish to achieve through our project, the Collab Box. Our team has developed a collaborative video game with an accompanying console, both customized for the students at Local School. With this, we hope to imbue a sense of unity, as well as provide a fun and engaging learning platform that requires minimal supervision. Collaboration, being our main emphasis, not only enhances social and interpersonal skills, but also develops self-esteem and confidence amongst the students. After careful analysis of the data, we narrowed down our target users to SEN students who are categorized as high ability in terms of physical dexterity and higher cognitive abilities.
Students will be playing the game in pairs, with a split-screen model and a storyline that completes only with joint efforts. We aim to imbue a sense of unity and collaboration amongst the students. To facilitate gaming experience, the ideal classroom setting will have students sitting in a pair, with a desk in front, and they will all be facing the screen in the classroom. For the pair of students, on their desk they will find a laptop linked with 2 game controllers. When the game starts, an introduction scene will be shown with virtual Pepper giving out the background of the story. Pepper is a humanoid robot owned by the school, and our team is doing voiceover for Pepper as students are familiar with its face. This also leaves the space to incorporate physical Pepper into our design at a later stage. In our latest version, the theme is set to be traveling around Hong Kong on trains to complete different tasks. Then we will come to the tutorial scene, where game instructions are delivered, and students get to adapt to the movement with joystick and button. It is now time for the game. When a pair of students is playing the matching game, the other students will be watching a video compilation, displaying photos taken around Hong Kong to engage them while waiting for their turn. They can learn about places they will be visiting in the game. The console required for jacking and matching pictures, containing a joystick and a button, is finely tuned to suit the physical abilities of the students. Regarding the core game content, it requires students to match correct pairs of pictures. The content is selected after discussion with teachers, aimed to challenge students at an appropriate level, and offers students a chance to recall previously learned knowledge. The storyline for the first edition is chosen to maximize attention and is based on the observed favorites of the students, like 12 trains and food.
Shown here is a small preview of what happens when you get an answer wrong or an answer right.
To facilitate students' engagement and attention, Collab Box is also taught with both intangible and tangible rewards to recognize students' efforts. Students will be rewarded 1 virtual star for each correct answer they make. It will obtain half of the octopus cards virtually when they complete their own part. They will also receive a physical sticker for that. The player can only combine the two halves of the octopus card in the game when both of them complete their matching, and use the octopus card to travel to another place to pick up their classmates. Tangible reward for the players will be assembling train tracks, and the photo shown here is a previous prototype of train tracks that we made from cardboard. When all the students finish their game, they can complete tasks on screen, for example, going Yamcha together. Physically, they get to connect the train compartments together and run it on the tracks that they previously assembled. We have also designed some skin for the toy tracks, so that they can look like the light rail trains.
Let's check this tissue paper box out. Well, it's actually our input device. This box, which is the box in Cola Box, was 3D printed with ABS filament, consists of 3 layers: the lid, the container, and the base. The bottom of the base are 3 suction cups, which helps the holder stand steadily on the table. Our holder holds 4 items, which size, however, is only half of a tissue paper box. So what's inside? First, you may see a blue board, which is the Arduino board that maps players' inputs to Unity, which is a platform where we have developed our game. And what else? Ta-da! A Senva joystick. This little cute shaft extender costs 20 HKD. However, it works. The shaft extender has optimized the length of the joystick, and this ball-shaped grip might support easier movement for students who have more physical challenges. Last but not least, there's also the Senva button and a board which is called breadboard, but it has no relationship with bread, so please don't eat it. Now you're feeling tired and wanting to change a position? Sure do. Within 10 seconds, players may land the controller on their lap if they want, just by removing the base. The holder also avoids tripping, as only one necessary USB wire is exposed to the ear, while the rest is hidden inside the holder. Little exposure to air also reduces damage to the joystick and the boards due to dirt or liquids. Isn't it cool, huh?
During this self-learning process, we've explored several applications. Our software department has made use of Unity platform for game development and Adobe Animate and Adobe Illustrator for fabricating animations. In hardware department, we've got Arduino for building and coding the console, as we mentioned, and SolidWorks and Fusion 360 for 3D modeling, which proved to be essential parts when our final joystick holders were printed by Upbox. We've also used laser cutting for our track prototype. Last but not least, taobaoing is a fun-to-go process, through which we got our Senva joystick train set, which are used in the reward mechanism.
Since fall 2019, we proposed numerous ideas, the major ones including a mechanical arm for physiotherapy of students, installation of LED light system across the school to help students navigate, and using Pepper, a humanoid robot, to make classroom learning more fun and futuristic. But in this semester, because of the online nature of the course, we made the best use of our resources to form what we now call the Collab Box. Even after the inception of the idea, we made multiple modifications in terms of the storyline, the game format, the form and shape of the controller, and the appearance of the reward mechanism. All these changes to best fit our target audience.
Our first round of testing involved some random kits and a cardboard prototype. Yes, it's a bit far from a computer game, but I confirmed that kids could understand the idea of a split screen and did get motivated by progressive rewards. Most importantly, the kids helped each other out, which was a huge confidence booster for us. We then moved on to develop the storyline, hardware, software, and the reward mechanism. Initially, our story was about a group of animals trying to escape a zoo. One of the faculty advisors then reminded us that the students might not actually see a need in escaping a zoo. They might think it's brilliant to be taken care of by people. This experience has pushed us to constantly put ourselves in the shoes of our users to create something that's relatable to them. Our advisors always give us a fresh and macro perspective on the game. We also held a Zoom meeting with teachers from Caritas and showed them our ideas. Since we could not meet the students directly, the teachers' advice was very valuable as they knew their students the best. We made changes to elements like creating characters with students' own photos to increase engagement, and replacing instructions involving concepts of left, right, up, down with arrows to make our game more easily understood. In these field days, we'll be sending our game and the console to Caritas. Boarding students still living at the school will be playing the game. We will evaluate students' interest in our design, their adaptability to the new hardware, and whether the level of difficulty is appropriate for them.
We have prepared a set of user guidance for our facilitators and our players. This include but not limited to safety precautions, procedures for both virtual and physical world, actions required by players, and actions required by facilitators. For details, you may refer to our supplementary document, User Manual 1.0.
With questions related to food, shops, and clothes, students have a chance to practice thinking about this topic which might not be covered in their lessons. Our product can engage students in a fun manner without requiring extensive instruction from teachers. Working closely with Locken School, our product is also tailored for students there. They could grasp the game smoothly as some of them are used to using the joystick on electric wheelchairs. However, we are not sure if the lower ability students could play this game, as they may not understand our storyline, hindering their attention and motivation, or the concept of matching itself. As our current model features only one player playing on one computer at a time, we could have to come up with a more effective strategy other than playing a slideshow on the projector to retain the attention of students who are waiting. However, we could minimize the negative effects as we modify the game to allow more pairs to be playing on more laptops at a time. We will also need to add more flexibility of the game, so the teacher and caretakers could set the number of scenes according to the number of pairs, and customize characters and the difficulty of questions according to the people playing.
Hong Kong, along with the rest of the world, is facing difficult times. This, coupled with the unique nature of our aims, posed several challenges that required us to continuously improvise and innovate different means of meeting our goals. The pandemic made school visits practically impossible, and some of our members have still not seen the school physically. Communication was difficult to maintain as team members were not always present on campus, or in Hong Kong for that matter. But also the school staff were occupied by taking care of their students, hence it was difficult to take out time to discuss issues at length. User input was also hard to obtain as it wasn't always easy to get the devices or the software to the school, nor were any members of our team allowed to be physically present to observe the students during testing. The project was also very technologically demanding. Members had to self-learn many aspects of game design and different software such as Arduino programming for input devices, Adobe Animate for the animation, and C# for the game design itself. Some aspects of the game required more advanced computing concepts, and the literature for our design wasn't always available. So a good amount of testing and intuition was required to close the gap between what was available online and the needs of our product. The game depends on the input devices sending information to USB boards and the Unity engine receiving them. While we have proved this communication works, this involves serial port USB or USB board information to be mentioned in the code. This information might vary for different systems that may want to play our game. We need to design a USB Human Interface Device or HID to adapt this concept to any system that intends to play our game with our controller. There was also a gap between the expected and actual level of the students' abilities. It was already difficult to design a game for such a broad spectrum of learning and physical disabilities. As the semester went on and we got further along with the project, we learned that our initial game designs did not meet the actual needs of the students. Hence, we need to continuously adapt the game based on reviews from the teaching staff. Some features, such as the match player game design and the controller, still need to be tested with the students.
For the implementation in the summer semester, Colourbox team would like to propose for regular visits to the Caritas Locken School, especially students who will be staying at the dormitory. We would like to simulate for a real game in that 4 to 5 pairs of students will take turn to play with the game. We will also seize this opportunity to make our game content more customized. Well, in fall semester, we will proceed to multi-computer coordination, so our current target students in the more advanced class won't be waiting to play the game. We will also expand our target to students in the potential class. All the 6 student members of Colourbox team will be excited to continue on our current progress and contribute to our future project advancement and maintenance.